Welcome everybody. Today we're going to be doing a review of some debugging tips. A reminder of the quiz that's due tonight. I'd like to get a new quiz out the door tonight if I can. Homework 2 involving some basic linked lists will be coming out on Wednesday, so I'll be starting some linked list talk as well. How is the homework doing for everyone? Who is done? Some of you, two of you. Who is struggling? Handful of you. We need some time on it. All right, I got four brave people raise their hands on that, so they're struggling. How are your stacks? Do you have stack working? Yes or no? Yes or no? It's not a night. You can't say stack is working?
Yeah.
Yes or no? No. No. All right. So what is it that is making your stack give you problems?
There's a bunch of errors and I'm not sure what to do with them.
You know, let's do this. I'm wondering if we should do it together as a class, or Esther says, yeah. Not the assignment, just the errors. All right. I'm going to pause the video. Send me your email. How far are you?
I've gone through 10. I'm having issues.
Okay, so you're almost there. How close? Where were you stuck at? What was that? It's number 3?
The cube.
Oh, cube. You have stack working. So what are you stuck on the stack? Oh, on the pop. Andrew, I share your opinion. It's like when you stay up all night. Oh, let's give an extension to everybody. No, they don't deserve it. They have to suffer just like I did.
I'm just completely stuck because...
All right, let's do this. I'm going to do my best. I'm going to pause the video. Send me your... All right, we're back. We've got the chat. I don't think that there's anything that I'm going to be violating with FERPA here. I think we're okay. Online students, you can see and hear me again. Is that right? I need one more yes. I need to make sure. All right, good. All right, so again, I've never tried this before. I worry, of course, cheaters. I don't like people who just blindly copy other people's code without thinking. I'm going to start with Chad Richen's code. And Chad, this doesn't compile, correct?
No.
All right. So we're going to go over this together and see what we can figure out as a class. Let me close all but this. I got 4 lined up. If there's time, we'll do a 5th. All right, so we got Chad's in play. Let me make sure that I can get the online chat students here. And let's scoot that a little bit over here. All right. So we will just attempt a build to see what happens. We're not going to run it. We're just going to try building it. This is a great way just to take care of the compiler problems. All right. I do have, good, 39 errors. That's a good scary amount of errors. My columns aren't the best. I'm going to move these columns back over. I had to scroll over to see them all. And I get a bunch of errors starting in line 159. I'm assuming you haven't modified the check test functions. Good. I'm going to sort by line number. This is usually a good way to get started. There are errors. There are also IntelliSense errors. We're going to ignore the IntelliSense errors. Sometimes they clue us in, but sometimes the IntelliSense, they're not compiler errors. So my first error says here on line 25, and do your best to read. I know people read, like, say the first 5 words of any error message, and then you kind of go blank. In the base class, in the pop, error in function declaration, skipping function body. And it's something here with line 25. And Do any of you see the error yet?
That's exactly like mine.
No, this is actually the body of the method itself. So this is one where the declaration and the definition are within the class itself. So that's okay. It is not missing a semicolon. Some of you are saying it matches yours. So what do you do here when the first error message tells you something and you can't quite understand what that means? Sometimes maybe go to the next one. Sometimes that's a bad idea. Sometimes it's a good idea. But we're already in a bit of a desperation mode. That's all right. I wouldn't say desperation's 1 minute in, but it feels that way. Same kind of error, line 25 seems to be a duplicate message. This one's interesting, line 78. Pop function template has already been defined. Oh, all right. So here's line 78. Do you see the problem? Nope.
Could we declare it above pop in 25?
Yeah, look at this error message. This one will clue you in. Function template has already been defined. So Alexis?
So, because we have the squiggly brackets up top, we defined it already, so we're trying to make another one.
Yeah, we're trying to define it a second time. You saw up here on line 25, we already have the curly braces defining it once. Here we're seeing another definition, and now it says this is CS2420 stack. This one is CS2420 base. So did we really redefine it?
So did we not define it in our stack class?
Like down in the
Yeah.
class 2420 stack.
Yeah, we didn't define pop in there.
Is
Yeah.
pop defined in here?
No. So it's inheriting the one that's already been defined, right?
It's inheriting the one that's been defined and it's trying to do it again. So this is actually one of those inheritance problems. So what could we do to fix this problem? One, I will allow you in this situation to modify. Let me put it this way. I made the base class so that it would compile right out the gate. But if you don't like the base class, if you need to modify the base class slightly so it compiles easier for you, that's allowable. Like you're not cheating, you're just making it compile still. Does that make sense? So this is one of those weirder problems where what do we do just to make it compile? Ideas.
You can either take out the.
Should I try taking out this one?
You can, or you can just define pop in your.
Or we try defining pop again?
Yeah.
Yeah.
Which one do you think we should? It sounds like a lot of you want to just define it again. Does that sound all right? All right, so it should be T pop like that. Let's see if that fixes anything. And there's errors, but do we have that line 25, line 78 error message about pop anymore? No, that's good. That means we moved on from that error. So our next one says size. In the base class, the size method uses non-standard syntax. Use the ampersand to create a pointer to member. Same error showing up twice. All right, let's double click on it. All right, so which class are we in, the base or the stack, or the derived? We're in the derived, and it's mad about size. I don't see the error. You figured it out. I don't have it yet.
Size.
earlier.
Let's
you
go look
made-
up. Let's see what we got about size.
Yeah.
Where's size at?
Size would be in your. It should be in your CS 2420 stack.
Is size in here?
No.
Size in here?
No.
Should it have been?
And
Oh, well, we got this guy. Current size. Is that what you meant? I got one variable here named current size. In your code, you called it size,
Yeah, I think so.
but then you called it current size again. So we're guessing that what? That should have been current size. So did that error really... Now it said use ampersand to create a pointer to member. Was that really the issue that we had? That wasn't. That was a compiler suggestion. Don't always take them as fact. Compilers tend to say there's a problem in near this region is the best way to describe it. Start looking in the general area.
Because in the constructor, there should be a capacity equal size, and
All right?
or values.
So does that build now? It does build.
Yeah.
Now, just so you know, I still have these messages. A lot of people were worried about that. Is this the problem?
No.
Why?
It's just warning.
It's a warning. It's my try catch block. It says, hey, you're catching an int, but you're not doing anything with that e. If you ever declare a variable, but you never do anything with that variable, the Microsoft compiler will ignore it. Or will give you a warning and say you're ignoring it. Is that what you want? In this case, I don't care. That's just a warning. Here are these... Here's some ugly IntelliSense. Do I really want to worry about core crt.h something or other? No, ignore the IntelliSense messages too. So even though it says 6 errors, those are really IntelliSense errors that we ignore. All right, your code now compiles. Is that good for you?
Yeah.
Let's go to the next one. Next up, I have Malachi's. Come back up to the top. No.
I'm gonna force it in now.
It's like the equivalent of high school. If the teacher isn't here in 15 minutes, we're legally allowed to leave. If you're not within your computer within 15 minutes, we're running the update. All right, we got Malachi's. I think we're ready to go. So yours compiles.
Yep.
What's your problem?
Run it.
I'm gonna laugh if it. Okay, it crashes. So stop. What do you do if it crashes? Number one, try to read the error message and pick out. This is how I handled my English class in high school. I don't understand everything. I'm just gonna pick out the words that I know and hope that's enough. It's not a good strategy for an English class, I can tell you that. But for computer science, often it's good. So unhandled exception, something, 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 int at memory location. So the biggest one is unhandled exception. I can tell you from experience that often means an error message was thrown but not caught. Okay? If I hit break, there's an error on line 76. And people, I've seen this a lot. People will send me emails saying, I can't understand it. It's crashing on current size plus plus. I've stared at current size plus plus for hours. And it doesn't seem to be the problem. Is that the problem? No, the problem is that error messages tend to give you general vicinities of problems. Is the problem right here? No, it was the uncaught exception in this line 73. Does that help clue you in a bit more? All right. So how do we debug this? My standard way is to try to not think as much as possible. Think to an efficient amount. Don't overthink. Take a look at your console and see how far do you get into your tests. I passed 10. I did not pass 11. Correct? All right. So I'm going to just hit stop. I'm going to scroll down to test 11. I know test number 10 worked. I'm not going to put a breakpoint on test 11. I'm going to put a breakpoint on the very next thing that's trying to run after test 10. Sound fair? Now let's take a look at this whole region of code, see what it is trying to do. The size is 0. I'm pushing on 2 numbers. The size is 2. I'm pushing on 3 more numbers. That should fill it up to 5. Am I at a size of 5? Yes. I should then try to push in a 20. Should I allow a 20? Why not?
Because it's already full.
It's already full. All right. And I run my code. I've got the breakpoint. The yellow line says here. Now how do I step in 2? That one, my F11. I will push F11. Now I can do F10s as step over. I don't need to step in 2 further. And it says the current size is 5, the capacity is 5, so it's throwing a 1, saying, hey, you're trying to push, but you can't. It's full, and it's throwing a 1. That seems to be correct, doesn't it? Malachi says, yes, that's what I'm doing. It looks correct. I've been stuck on this for a while. So, consult the instructions. What do the instructions say to do for push? Do you have the PDF handy? Do you really have it?
Not up right now.
Oh.
I'm getting it up right now. It says for
You know, I should pull mine up too.
push. This method should have a single parameter.
Hold on. I'm going to pull it up also.
Okay.
Push. Single parameter. Data type should be const. Const means it can't change. The push method should have a void return value. This method should see if the current size equals the capacity, seeing if it is full. If so, simply state an error message and return.
Wait.
Now Malachi's confused. It says simply state an error message and return. What is your code doing?
It's throwing an error.
But you think, well, don't you always throw in an error? Is that what's going through your head right now?
Yeah.
All right, what's my answer to this? I did cover this before. Do you always have to throw? When do you throw?
You can-
As rarely as you have to in my class.
When you have
Do I have to throw in the push? Why not? There's nothing I could return and get away with it. It's a void return type. If I had, say, a pop, where I have a T return type, yes, I absolutely have to throw because I have no other way to back out of this. Here, though I have a void, I can get away with simply saying, put an error message on the screen saying, hey, there was a problem. So I'm going to do this. I will say cout, there was a, or I'm going to do this. A lot of you have error, scary error. Be afraid. All right, so suppose you put this kind of an error message in your program. Sound fair? With a return, I'm fixing your code. We'll run it again. Here's my breakpoint. I'm going to bravely step over it. I will step over this. And where's my console output? Console, why don't you come out? There it is. Did it pass the test? Now, a lot of you have been coming to me saying, hey, my program has passed all these tests, but there's these scary errors in my program. What's causing those scary errors? Your own output that was there specifically to tell you that you were telling you what's the problem. That's good to have that output. If you have a test, if it says test failed, you've got a problem. If you have your own little output, that's fine. You okay with that? All right, let's go on to the next one. Brandon, that's boring. You have reached full capacity. Nah, no fun there. Let's go to the next one. We have Ryan. Ryan, so this one does not compile?
It's very close when I got it to compile.
Well, we'll find out.
Yeah.
All right, it doesn't compile. You can't say it got close to compiling. It's
Well, I changed it and then it compiled.
no, that's Rubik's cubing. Like I changed one thing and it compiled, but no.
It's just
Oh, I see the
yeah,
problem.
putting the less than in front of the equal sign right there. That's what it is. And then it'll
What do you see the
compile.
syntax mistake? What is it?
It's where you say current size equals less than, it should be less than equal to, and I don't think you need to do this current size.
It's okay to say this current size. In fact, a lot of folks, yeah, that's fine. In fact, a lot of the Mac Linux users have to.
Oh, okay.
So it should be less than or equal to. Equal to and less than doesn't work.
Yeah.
As a side note, something like that will compile in C++. Is that what you want?
No.
This is one of the harder ones to find. Why? What's that doing?
It's making.
It's
current
assigning
size.
the value of capacity minus 1 into current size. That's really not what we want. You would want a double equals. But here it was less than or equals, correct? All right, does that compile now? It does compile. So now do you have runtime errors?
Yeah, runtime error was on like the first test.
All right. We got a good error right off the bat. Unhandled exception, something, something, something. Look at how far we got. Output was, what does that tell me? Garbage data. Should have been 1. Capacity field. All right, so we weren't even passing test number 1. Let's debug it. So I'm going to hit break, stop the program. I am going to come down to looking at test number 1. Something is happening in those 4 lines of code. So I will put a breakpoint on line 201 and we'll run it. I will step in, and where am I? Where did it take me when I stepped in? Where in the class? The constructor. I remember the first time I would debug, I got so mad about how much my arrow would jump all over the place. Like, where am I? I'm jumping in, I'm jumping out. Know where you are. We are in the constructor. Take a look at it carefully. This array equals new t size. That looks good. Capacity 0. Current size is 0. Capacity is size. That does look okay. I'm not. No, that's all right. All right, so that looks okay so far. It does come here as well. Gets that set up. Array is null pointer. Now it's actually something useful. All right, let's go into push. Step in 2. Let's see what it does. First check. Current size is 0. Capacity minus 1. Is this a true statement? It says false. So if, and that thing comes out to be false, and that's what we expected. The capacity wasn't filled, correct? All right, so this array at current size equaling as being assigned our data. Look good? Increment current size plus plus. Does that look good? All right, so our push seems to be good. Let's go look at our pop. Step in. If current size equals 0, You can't pop an empty array, but we avoided that error. We're okay now. This current size, you're decrementing it, correct? Because current size was a 1, now it becomes a 0. And now you're returning the data at this array current size plus 1. So you're trying to return the data at index 1. Is your data, where is your data?
It's at 0.
It is at 0. But where are you trying to return it from?
1.
1. So what do you do to fix the problem?
Get rid of the addition 1.
Get rid of the addition 1. All right, let's try it again. I will quickly just step over. We pass the test. Are we good with that?
Yeah.
I'm sure there'll be more breaks coming up, but I'm going to stop there.
Alright.
So that's just a straightforward debugging, helped us understand what the program is doing. If you just stare at the code, you don't really see it. If you debug it, you see the problems much, much faster. Grace, what's your code doing?
I'm pretty sure it's my prop method too. Kind of like the same as his issue. I'm getting garbage.
Okay, so yours builds.
Yes.
We'll do a quick initial run. Ah, that's what I like to see. Errors everywhere. So don't. A lot of you are just like, you know what? I'm going to tackle. I don't know why people do this, but I see it a lot. Let's tackle stack number 14. 14 is a good number. Let's try to get that error figured out first. I don't know why people are doing it from bottom up or somewhere in the middle. No, what should you tackle first? The very first error. All right, so your number 1 is also causing problems. Let's go look. Where's stack number 1? It's a good sign you haven't modified the test code. I'm happy to see that. Step in, where should this take us if I step in? The constructor. Does that constructor look good to you? Yep. And you even put lots of comments to help tell you what's going on. That's a really good way to program.
Always.
Now, in industry code, don't comment this way because people are like, yeah, I know what that's doing. You don't need to but when you get to your own code, it's like, I know I can mark this as done. I did it. Come back out. Now we're going to go into our push. Is there room? There should be room. So you're saying array at current size is our data. Does that look good?
Yes.
Looks good to me. Increment current size? Looks good to me. Let's go look at the pop. Step in. Are we in a bad state? Current size is 0. No, we're okay. Return the array at current size. Is our data at 1? Grace isn't sure yet. That's fine. It hasn't clicked. If it would have clicked, you wouldn't have had this bug.
Yeah. Pretty much.
All right, let's draw it out. So the idea again of our stack object is that it has an array on the inside, or an array pointer, correct? There's 4 elements, or 5 elements, from index 0 to index 4. And our very first code was actually writing in the value 1. Where did it put the value 1 into the array? Okay, so it put it right here, correct? And then, oh, my darn eraser didn't work. Let me see if I can fix that real fast. Which one are you? Which code are... Still didn't. Okay, we'll do the double. Turning it off and on again. I hate computers. Like, oh, there we go. You also have a current size in here, correct? And after you wrote it, you upgraded your current size from a 0 to also be a 1, correct? All right, so this is what happened when you pushed. Now when you're popping, according to your code, you are saying return the array at current size, which is 1. Grace just gave me this, oh, I think
Maybe. I think it might be.
All right, so you're returning the array at current size. What's at current size? What's at index 1? Garbage. What did you want? You wanted to return the data here.
So I need to switch them.
Oh, careful. So you're,
Oh.
all right, so you want to switch. Do you like that idea? You want to decrement current size first,
Yes.
and then return it.
Sure.
Now that's also good because if you can you ever run code after a return statement? This is an immediate something's wrong. Now does that make more sense? It does. And in fact, some Visual Studios let you modify little bits of code and it compiles it on the fly. It's a feature that shouldn't exist and it does. So be very thankful. Okay, it compiled it on the fly. That's ridiculous that it can do such a thing. That's wizardry right there. All right, so current size is now 0. And I can take a look. What's an array at 0? What value's there?
1.
Or 1. And does it now pass our test?
Yes.
It does. All right. Did you want to do yours? Okay, I gotta pause the video for a second here.
They all work now.
All right, we're back. Let's take a look at one more, which was, is this one you, hold on. Where did hers go? Let me pause this for a second. I know, but that's okay. You could just see her email. All right, we're back. This is Manal's. Let's see what it does. Does it compile? No, lots of error message. 112. Let's see. Where is the comic for this? Oh, do I not have it? I'll have to go back and find it. It's a joke that if you have 47 compiler errors, you fix it, and now you have 112 compiler errors. That doesn't mean you have 112 errors. It just means that something triggered a whole bunch of other syntax mistakes. It was a catastrophic failure of sorts. Often it's just 1 or 2. Let's go in order. All right, CS2420 stack. Use of class template requires template argument list. I see the error. What's the error? The little T, chevron T. It looks like you got a bunch of those that you're missing. So I put 2 of those on. Our next error message, error in function declaration, skipping function body. So CS2420 stack, it's mad about this. It says it's skipping the function body. This is the constructor, correct? Do you have the constructor? Do you have the constructor declared again below? Is it being declared twice? I'm sorry, declare is here. Is it being defined twice? That is a definition. That is also a definition. Can you have 2 definitions? How do I fix this? Let's remove that definition. Let's build again. More errors. Problem here. T. Use of class template requires argument list. You're missing the T again. Let's keep going. There's another one. I notice it's also here. New error, peak, unable to match function definition to an existing declaration. So something is mad about this peak. So if you're not sure, just grab this guy. I did not get this one. I like your comments. So I'm going to copy that declaration, or that definition, the body of it, and let's take a look up above for the peak. Do you have a peak? What? Where's your peak? Oh, is this your peak? Do you see the difference? What's missing? Well, there's two problems. One, you do need a peak down below here. What's the second problem? Do you see the second issue? There's actually I see two problems. The signature has to match exactly. You've got a const here. Does this peak have a const? It probably should have. That's probably my mistake, but it doesn't. The peak has a return type of T. What is your return type? Is that a T? No. So we need to make sure it matches. So first, let's grab that. We'll fix it. We'll put a T here. You don't need to have the class there. It knows it's in the class. And we're going to get rid of our const. So that's what the peak should look like. In fact, should your pop be const? And we'll come back to that one. We got our peak. This is a good one. Let's get rid of that const. Change that to T. Try building again. All right, more errors. You're going to have a lot of errors. This is good. This is exactly what I wanted to see. So what you did is you violated one of my important rules. If you try to write it all and then fix the problems, that's a terrible way to program. You write just a little bit at a time, get that little bit to work before you dare move on. Because you try to do it all at once, now we're trying to fix a whole bunch of problems, and that's really hard to do. Alright, so this is something with a Q class. You've got a TQ array going on in here. You know what I'm going to do to your Q class? I'm going to, just to get this thing to compile. Alright, so I commented out your Q stuff. I'm not caring about Q, I just want stack to compile. More errors. Something about a semicolon. Void should be preceded by a semicolon. You see the error here? I see it. Wait, do I? Do you guys see the problem? This is a harder one. So if it says void should be preceded by a semicolon, does this really need a semicolon there? No, but maybe we're going to go then to the general idea of maybe something is wrong beforehand. So take a look beforehand. Is there something wrong here? What?
You're defining base twice.
There's two constructors.
There's two.
That's fine. Can you have two constructors?
Yes.
Yeah, do you need two constructors for this homework assignment?
Yeah.
No. Which one do you need? The one that passes in a size. Which one do you not need? That one. The default. So we're going to get rid of that, and let's verify down below. Well, that was just the base class, isn't it?
Yeah.
Like, I didn't sneak that in the base class. She added that in, right?
No, it's
No,
on
it's
there.
in there.
Is it really?
Yeah.
Oh, well then I'm wrong. Well then what's the problem? Let's go take a look at your constructor. There's your constructor. There's your destructor. That belongs to the stack. Stack, stack, stack. I put this there and it worked for me. I probably shouldn't have put that there, but I did. Okay, now I'm stumped. Where's the problem? Maybe if you compile it again, it'll go away. No, it didn't. You know, I'm going to come back on this one. Let's go grab this guy. I know. I'm going to fix the Q one so they compile at least. Got it. You forgot those T's in there. Yeah, it's more mad about the Q again. Sorry, just gotta make the thing happy here. What is it about the Q now that's mad? I don't want to deal with the Q.
Can you just comment it all out?
Oh, I've got a... It's declaring it here. That's what's mad. I had a curly braces. It was defining a constructor body.
So, yeah, you put those in there.
Not for the Q. Oh, for the Q, I put those in there? Yeah, you have to get rid of them.
Oh.
So it compiles. And then we've got more Q stuff showing up in here. I don't care about this guy. Just get rid of that. I always want this thing to compile. More Q stuff. Leave me alone, Q. There's the T. I get rid of... Alright, we're back to stack stuff. This is good. Size. Let's see if we can tackle this guy. Function, stack, size declared at line 47. Oh, that's the IntelliSense error message. Ignore that guy. This one. Same problem. Cannot access private data member declared in class. All right, let's go solve it. You should have had... I see the problem. It says it can't access a private data member declared in the class. What's the problem?
She has an unsigned size.
And what is this size? Is that a method? Yes. How do you know it's a method? That means it's a method. If I didn't have that, what would it become? That'd be a data member, but it's a method, correct? So, can something in main access the data member? Private. I'm sorry. Can a thing in main access something that's private? No. So how do we fix it? Should have been public. Keep going. Hold on. Stop. Down to 6 errors. Cannot convert from in. Ooh, this is a good one. This is a really good one. Initializing cannot convert from int to std basic string char, std char traits char, std allocator char, or something.
Did we go over this one in class?
Yeah, this is, yeah, we have. You went over this in 1410. But it's not obvious. Okay, so we know we have a problem with this line 279. Okay? What's the problem? We don't know yet. We know that there's a pop. Stack pop is trying to write into string temp and it's just mad about it. Let's go take a look at our pop, see if we can spot a problem. Where's our pop? All right, here's our pop. Does that look good? Malachi says no. Another student says no.
No.
Jeff says pop is returning an int, not a t. Is that the problem? Yes. So the pop is hard-coded to return ints. And it worked when the pop method was grabbing ints, but I have a test where the pop needs to grab and return a string. So it's mad because this guy is returning ints, trying to assign it into a string, and the error message that resulted was cannot convert from int to string. So how do we fix it? A T. So this pop should be T. That's the declaration. Should it be const? Does pop change the object? It changes it, so it should not be const. Let's go look at your pop down here. That shouldn't be an int. That should be a T. That should be a not a const. Try again. 10 errors. Current size is undeclared identifier. Size. At least that one's obvious. There's a lot of times where you don't see, like, you throw in a third R and it just blends in at 2 a.m. Like, I don't see the problem. What is it?
Or like when you're using I's and J's for your indexes, and
Yep,
they
yep.
look so similar that you realize.
Oh yeah,
you don't-
spelling bugs. They're obnoxious. You get good at becoming like an English copy editor. Like you just start saying things out loud, letter by letter. So current size is equal to 0. Equals cannot convert from int star to int. That means can't write a pointer to an integer. Where's this at? All right, line 71 is the problem. I see code like this all the time. It's confused code, but I understand what you're trying to do. You're trying to say, in the array, at that index, write in the data. Is that how you write the data? No, what does new T return? It returns a pointer to the thing. Do you write pointers to things in there? So how do you return the thing? How do you write the thing on in? The problem is, you never even gave the thing a name. You left it off. Push. What's push receiving? A piece of data. Somehow item disappeared. Manal's done. I can see it on her face. I give up. This is normal. Everybody goes through this. So we know it should be item, which means we should be writing item on in. Let's keep going. 7 errors. Push. What was the error message? Void function returning a value. Do you see the problem? Should push be void? Yes or no? Hold on, you just changed your answers twice. Tell me, should push be void? Yes or no?
No.
Push should not be void? Why?
Should be void because it doesn't make
Okay, it should be void because it's not returning anything. Alright, so your code is returning something. Should it return something? So we can just say return, or you don't even need return. Does that make sense? Alright, let's keep going. This is an excellent code example. I'm really happy you did it. Thank you for submitting it. More. Size, non-standard syntax, use ampersand. We've seen this before. Use ampersand to create a pointer to member. We learned it was wrong. So let's jump to see what it's got. If size equals 0, stack is empty. What's the problem? Should be current size. I'm glad you caught that one. The issue is, and the reason this is mad, is you have a method named size and a data member named current size. And so it's trying to say you're checking as if the method is a 0 address. And that's where the compiler gets all confused. Data member, keep going, keep going. Illegal else without matching if. You don't have curly braces on your if statement. Please put curly braces on everything, even if it's one line. Some of you try to be sneaky and say, oh, here's a weird else. Return and a second return. Which return should it be? I think both of those are wrong. We'll come back to it. Does it compile? No. And then get right to this point again. What should be returning here? It should be returning one thing, and what should it return? A size? No, what's pop returning? According to the instructions, you're supposed to decrement current size. Then what? Return the array at that spot. So current size is an index, not the actual data. Let's try again. Peak must return a value. Anybody want a clue or in here? What should happen? What should... Return current size here? No. Do you return the array at current size? Should it be current size minus 1 or just current size? We've got 2 to 2. 2 of you said minus 1, 2 of you said don't minus 1. If you're not sure, draw a picture. I've got some data here at 0. Current size is 1. Let's make this data a little cleaner. I don't like it when my data is a 1 and my index is a 1. It's confusing. Come on. There we go. Suppose this is my stack at the moment. I've got a piece of data in there. The current size is 1. At index 1 is garbage data. I'm doing a peak. What should it be returning? The array at current size? What's the array at current size? Garbage. What should I be returning instead? The array at current size minus 1. Now compiles. Big lesson I want you to take away from this. Do not try to write all the code once and then fix the compiler problems. We got through this in about 15-20 minutes. It would have taken you much longer if you ever got there. It is much better to simply write one thing, test it, compile it, before you dare move on to the next thing. So I'm being mean about that one. Other questions here? Are we okay? Yeah, Chase, that's all wrong, whatever you're trying to do here. You don't do it that way. Oh, you declared it. I see what you're doing. You declared it as up in the base class. I see. Chase, you should have been able to get away with saying this ARR if you declared it in your base. Chase is saying that he put his ARR up in the base class, not in the derived class, and then he wanted to access it. If that's the case, you need to say this arrow ARR so it knows how to go grab it out of the base class. All right, I have never done that before in all my years of teaching. Was that a useful exercise? You think? All right, well, it's because the critical thing is not can you understand the data structure, it's can you do it by yourself. That's the hard part. So it's good to know. I'll see if we can do more of this without showing you answers to things. Boy, and I still need to get some time. I've got about 15-20 minutes. We need to jump into linked lists. No, Nathan, I really want to spend a full week on debugging approaches and styles and techniques. I want to keep doing debugging approaches. All right, so we're going to do a quick overview of arrays. There's some things about arrays that are interesting. Let's talk about their good and their bad. Arrays are nice containers. They're meant to hold data. We can allocate them on the fly. We can deallocate them on the fly. But they're not the best data structure. They're not the best container. So tell me, what's something that's good or bad about arrays that you can say, that you know right now? Is there anything bad that you just don't like about arrays? They have fixed size. What does that mean?
Countdown to goodness.
Is that what it said? I looked at the update. It didn't give me anything but exciting. It was pretty boring. There's a new task view. I don't care.
He said I do PIN to unlock my computer instead of like putting in a full password.
It does what?
Like I only have to put in like a 4-number PIN now to unlock my
Oh, really?
laptop instead of a full password.
So they are fixed size. What does that mean? Like,
It means once you place the size, make it a size.
can you make it larger?
You can add more past it, which is another.
No, you shouldn't be writing.
Yeah.
So there's no bounds checking. That's another one. You can't make it larger or smaller. Correct? No bounds checking. What do I mean by bounds checking? Yeah, I can write outside. It doesn't know its own size. So you can write on either side, the left or the right, and that's actually a huge, huge problem. A lot of the security flaws, a good chunk of the security exploits, come straight from this issue. You find something where there's no bounds checking, and you start writing outside array bounds, and you can do silly stuff in the program stack. Doesn't know its own size. What else? It's not good. You can't remove a middle item. Does that make sense? Like, let's say you've got 10 items and the thing in the middle, you just want to get rid of it entirely. Can you splice the array in half and glue the two chunks back together? No, that's not allowed. What else about arrays that we don't like? Anything else? Has fixed size, it can't be larger, can't be smaller.
The template, using templates fixes this, but it's very, like, you can't put doubles in there.
So that's not a bad, in my opinion, it's not a bad thing. You're saying I can't put a double into an int. About 15 years ago, computer science was really trying to go down this crazy heterogeneous collection where you can throw any kind of data type in any kind of collection. And people kind of liked the idea, and over time people realized it was a bad idea. And almost every language has backed away from it. And only a few legacy languages, and I'm going to call JavaScript a legacy language, still has that garbage still in there. And everyone regrets that decision.
Chase just said a really good one too.
I don't like that static arrays can be defined with a size later down the line.
Where when you declare a static array, you have to declare the size as well.
Oh, that's a compile time sized array versus a
Like a dynamic.
dynamic
You
array.
can, you can make the dynamic array and then later go, I want the size to be this. At compile time, it has to be that.
Yeah, there's a lot more fixed nature to it. Is there anything good about arrays then? No, we hate them. Why do we use them then if we hate them? There is some.
I love arrays.
They're good for learning. It's a standard academic exercise. You learned it this way. Now let me show you why that way is garbage because of this better way. No, there is something really, really important about arrays.
I think
Nathan has it. They are fast. They are really fast.
they're good at.
Why are they fast? How do I say it? They play nicely with computer architecture. And we'll go over this another day, not today. And they also are something called random access. And I don't mean that you just, it's not like Las Vegas slot machine. Hey, I'd like an element of the array randomly, please. Okay, here's index 58. It's not, no, it's in other words saying, You give it any random address and it should be able to go to that address at the same time as any other address. That's a real nice part about arrays. You can jump right to it. They are basic and low level. If things are basic or low level, that means algorithms written for arrays are going to translate to phones, to little hardwares that don't give you many options. It's the most common container out there. So there are a lot of good about arrays, but largely in industry, unless you need these goods, you avoid arrays entirely. For example, if I go into Google and I say arrays are evil, I will get a whole bunch of arrays are evil, arrays are evil. Why are arrays are evil? Blah, 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 blah. Lots of good stuff there. So what we're going to do is come up with another system, or another data structure called linked lists. And linked lists flip the goods and bads. So everything bad about linked lists now become good. In other words, they don't have a fixed size. We can add to them. We can shrink them down. We can remove items out of the middle. They know how big they are. You can't go outside of bounds of a linked list. It's nonsensical. It's a nonsensical concept of a linked list. But it's almost as if computer science is a religion. Anytime you have something good, it always comes at the cost of something bad. There is no free lunch. In this case, everything good about arrays become bad about linked lists. In other words, are they fast? No. Do they play nicely with computer architecture? No. Are they random access? No, you can't just jump to the 54th item. Are they low level and basic? Not really. So we get a whole bunch of good stuff at the cost of some bad stuff. And it depends on the application. Is it worth it to you or not? And that's where you get to make a computer science decision. There's no hard, fast answer. Yes or no, you just have to make your judgment call based on the situation at hand. All right, we've got a little bit of time. Let's keep going on this. Nathan asks, how similar are vectors to linked lists? In C++, the standard template library, vectors are just wrapped arrays. The lists are, of course, linked lists. So if you ever do need an array, but you want to have some of the safety checks on it, try to use a vector, the STL library of a vector. All right, so now we got to talk about what a linked list actually is. A linked list is composed of node objects. And the node object at its most basic level can be thought of as having your data and a pointer to another node. In other words, we're going to link these together as if it's some kind of like a snake or a chain. We are going to create a collection of node objects that know how to point to other node objects. I'm going to put a null pointer on that last one. The idea is that we can say this guy is the start of our data. So if I were doing the example homework assignment, I had, I think, these numbers. I don't remember what the last number is. I think there was a 14 in there. So you can put your data in the node, and each node also has a pointer to the next node object. Does that make sense so far? So these nodes can be thought of as a linked list collection, but I'm going to go one step further and create a linked list object itself that manages the nodes. So this guy is my linked list object, inside the object, I am going to have a pointer called front. I will have a pointer called back. And I will, because the book does it and a lot of people do it, I will also have a value called size or current size that keeps track of how many nodes are currently in my list. Does that make sense so far? So in this situation, there are actually two classes involved. We have this class, which is the linked list object class. I will also make a node class, which defines a node. Now a question was asked over here by Chase, should I use structs or nodes? Turns out that in the C++ world, classes and nodes are almost always identical concepts. The difference is classes, things are private by default. Structs, things are public by default. Structs are kind of a way to clue people in that it doesn't have to be this way, but structs usually mean data members only, no constructors, no methods. So a lot of people will make these nodes structs because they don't have methods. I'll leave it a class. It's not a big picky issue to me. But overall, I'm going to need to create two of my own containers, or my two of my own objects or classes. And the linked list object has to manage node objects. Make sense so far? Questions on that?
Clarification here. So you're just creating an object, or well, technically two objects.
No, on the screen there's technically 5 objects, or 6 objects.
Yeah, but or classes is what I meant.
I'm making 2 classes.
And you're just simulating how an array works, but not like all the.
So I'm not simulating how an array works. I'm making a container.
Yeah, that's what I meant. Yeah.
And a container just holds, you think of a container is an object that can hold 0 to many items. And that's what I'm making here. I need to make a container that can hold 0 to many as many as I want of other stuff. Sound fair? Now, just a quick check. On the linked list, could I easily shrink this linked list? Yeah, could I get rid of this 14? How much work does it take to get rid of the 14? Or no, let's get rid of 12. Is it easy to get rid of a 12?
You just make your front point.
Yeah, we'll make the front point to here, and then we'll just get rid of that guy. Was that hard to do? Did these guys know anything changed? Could I have done the same thing with an array? Could I have easily got rid of a node? No, resizing with arrays is a nightmare. You have to make a whole new one, copy all the old stuff to the new stuff. Ugh, I hate it. But here I got rid of a node. Let's get rid of 47. Could I get rid of that guy?
Yeah.
What do I do?
You take out 47 and then make 32.
Make 32, point to here, and I get rid of it. Sound fair? Now that's the picture point of view. In code, it's going to take a lot more work. You have to be much pickier about exact orders of things and not losing things. And so it's not as simple as just saying, oh yeah, in my picture I can get rid of it. Do it, but we got to go through some exact processes on it. We'll talk about those exact processes tomorrow. But for now, let's start by actually declaring these two data types or data structures. So let's go into an empty file, start it anew using stdcout, std and l. What was I have 2 classes. What's my first class? I'll make node be the first class. And I'm going to templatize everything. Chase, that seems wrong. I don't know, it might work, but everything about it feels wrong. It'd be like trying to wear polyester suits to work. you know, bright plaid polyester. It could work, but it's not a good idea. All right, we got our class node. How many data types are in my particular node here?
However many is the-
Take a look. It's not hard. How many are there?
3.
No.
Oh.
Look at a node object. How many things are in there? How many data members? 2. What's the first data member? Your data. What's your second data member? A pointer. You got that? Now, this is one of the rare times where I will make public data members. Almost always, object-oriented programming has private data members. Very, very rarely do you want public data members of a class. But here I'll do it, because these are very simple little node objects. All right, the first one was our data. What's the data type of our data? T. And I will use C++ saying default initialization. If this T can be initialized to some basic value, let's do it. What's the second data type?
Pointer.
And it's a pointer. Now I can't just say pointer. Unfortunately, that's not.
Oh, no.
So it's a pointer to what? It's a pointer to the next node. So you always have to say it's a pointer to a data type. So it's a pointing to another node object, correct?
Right.
So what's the data type of what it's pointing to? Another node object. Make sense? And I will call this guy, I'll call it link. And then I will throw null pointer on it as well to initialize the guy. Anybody mad about this yet? Where's the constructor? Does it need a constructor? Is anything being dynamically allocated in the heap in the node class? Is it creating a file on the hard drive? Then there's no need for a constructor. These guys are being auto-initialized to their default values. We don't need a constructor. These curly braces mean if things can have a default initialization value, like inst initialized to 0. So if T knows its own default initialization value, it will initialize data to that.
You got caret T on the
Oh, it turns out you don't. Oh, this one? This one? No. You don't need it here. And because node knows it's pointing to a type of its own, the T is actually too much work. You can get away with it in this case of not needing it. All right, let's do the next one. That's all we need for our node class. What's our other class? The linked list. How many data members? 3. So template, type name T, class, I'll call this guy linked list. I'll throw in a public and a private. These data members should be private. What's the first one you want to put in? Front, size, or back? Front. What data type is front? It is a node pointer. You got that? Here I have to say node T, because this template is different than that template. It doesn't know, okay, you're pointing a node of what type? A node of the same data type of the linked list. So node T pointer, and what did I call it first? Or front? Front. And we have a second pointer, back. Let's get that in there. I'm going to null pointer these guys before I move on. Null pointer. Back. All right, and I got my third guy. I called it size. Should I call it? You guys like current size or size? Current size. What's the data type of current size? Better than, I can do better than int. Can I do better than unsigned int? No. Should the size change?
Yes.
Well, yeah.
So should it be const? All right, unsigned int, current size. I'll initialize that guy to 0. And we will start with just this much for now. So we're going to leave at this point. Chase, if you're trying to show off, there is something called the long data type.
Yeah.
If you ever need a 64-bit integer, they called it long. The dumbest name I've ever heard them come up with. They should have just called it long 64 and long 32, because then I hate that. The worst thing I've ever seen. Anyways, there's our size. So next time we'll talk more about some of the basics of linked list methods. I want to do a simple linked list assignment, a little 1 weeker, and then we can up the ante and make a harder linked list assignment for the next week. And then we can jump into more fun, it's like doubly linked lists and iterators after that. So we're going to have at least 3 linked list assignments, maybe 4, coming up. We take a while to get all these details down. Zach asks, any pointers for tonight's quiz? Other questions?
Participation code for tonight.
Oh, I forgot about that. Let's get some numbers here. Do I have numbers on the screen? I don't have enough. Oh, I do. It's right here.
32.
Come on. For a coolness bonus, what's significant about those numbers?
They're all prime.
No.
No.
14 is prime. What? Jeff Hornacek is all 3 numbers? Jeff Hornacek's 14? Then what about 32?
That's Carmel.
Carl Malone? Then what about 53?
I want to say.
No.
It's not.
It's the really tall guy.
Mark Eaton.
Mark
I'm too young for to see Mark.
Question is, which order is it in?
It's that order.
That's a fair response.
Chase, oh, you're I'm failing you right now. You're out of the class. So the next class period, we're going to talk about the jazz, nothing but the jazz, and just focus on the jazz, with emphasis on the jazz. All right, remaining time, I will come around, help you with your homework assignment. It is due on Wednesday. I'll get a new quiz out the door tonight, and we'll see you on Wednesday.
So I do have a question about that. I submitted it already, but I realized that my error message that stack is full for the queue.
But it still passes the
It
test.
still passes
You're fine.
the
If you
test.
ever want to go fix up your code, you can always submit a later one.
Okay, but that.
And we'll
that's
always
not
just
big.
grade the latest one.
Okay.
And if you submit another one after and then you make your assignment late, well, then you just made your good assignment now late, and now you get half credit.
Oh.
So you can still do that too.
If it doesn't matter, then I don't really mind because it still passes the test.
Yeah. No, Justin, but I'll take care of you in the future. You'll be all right. Andrew, the Suns hired the Jazz assistant coach, so they are in for a good thing next season.